a very interesting problem with LeetCode. It is sort linked list. So basically, if we know that if we want to sort a array, it would be much simple with a lot of methods such as bubble sort or merge sort and quick sort. So today we're gonna apply merge sort in this case. We can think this linked list as the same as the array. Case for the array, right? So how to apply the merge sort in array. Right. So basically for the array we would define, let's say we would have two array 1 and array 2, and we want to merge them up, but the request for the array 1 and array 2, they are all sorted, right? So, and we can merge them easily because we can use 2 point. Let's say we have array 1, which is 2, 4, 5, 7, and sorry. We have array 2, which we can say 5, 8, 6, 3, right? So we could have, like, let's say 2 pointers point into the start of 2 array, and we will define a new array. We can call it new. Oh, this is wrong. Right? We should have a sorted array, right? So we can say this case we have these 2 arrays, and we want to merge them into a new array. So first of all, we have these 2 pointers, right? We have these 2 pointers, and we want to move them. So first we compare where the 2 pointers at. We compare these 2 numbers, 1 and 2, right? So in this case, 1 is less than 2, so we put 1 here, and we started to move this pointer, right? We move this pointer to the next one and compare it to this 2 number, and we can see that 2 is less than 3, so we put a 2 here, and we start to move this this pointer, the pointer for array 1, right? Move to the next one. Let's put a more obvious color. We can put like 2 pointer. So in this case, 3 is less than 4, so we put 3 here, and we continue move the pointer for array 2, and now the 4 is less than 6, we put 4 here. Yeah, you got this mean. So we continue move these 2 array and 2 pointers, and we got this algorithm to our linked list, right? Because now we don't have 2 sorted linked list, but we should know that the linked list can be separated into 2 parts, right? and we can continue to separate it and continue to merge each of them to our sorted linked list, which brings to a very common algorithm, which is recursion, right? Recursion. Yes. So now what should we do? So first of all, we should find the minimum length of a linked list, which is just let me put it this way, linked list. So we can separate this linked list into small parts. We can, let's say, separate this example into these two parts, but still these two parts are not sorted, right? So what we should do next, we should to continue to separate them into more into smaller part, which is, let's say, oops, it's 4 and 2 here, and now it becomes 1 and 3. Now it's more clear, right? We can because it's the most the smallest unit, smallest subarray here, and we can make them into our sorted list, which is we change the color. So 2 should point to 4, and we return this linked list, right? And 1 should point to 3. It's same, right? And now these two linked list is sorted. Now we can return to the root array, which is 1, 2, 3, 4. Correct. So that's how this algorithm would work. So this is how the algorithm works. So first basically we separate this solution into two parts. First part is to separate the linked list into break them down into smallest pieces, which is a single element, and we use recursion to do this part, to have the smallest part of subarray. And what we do that we should get each time we should get the middle of the linked list, and that's kind of a tricky part because we let's say we want to get here, right, each time, and here, and finally we do not have to do this anymore. We need to get the middle element. So how should we do that? So we can we have come up a solution in LeetCode. In LeetCode number A76. It's an easy LeetCode problem, which is to find the middle, get the middle of the linked list. But now we kind of do the different thing, but it's still similar. We want to get the middle. We want to get the middle, and we want to separate the linked list into two parts. So it should be we get this node, and this node should point to none, right? That's how we separate to sub-linked list. So yeah, that's the first part. And then we should do the sorted merge sort. Merge sort would be just what I said, like we did for the array, which is two sorted sub array sub linked list, and we have two pointers point to each of them, and we get a small one to put the small one into the new sorted array. In this case, it's a linked list. So basically, let's take a small example here. To initialize a dummy node, and the dummy node would point to the smaller element, which here it's 1, and after that the pointer will move to the next element, right? And we want to compare this 2 and 3, and we now see that 2 is less than 3. So we take, this is the key part, we take this, we take this pointer to here to point to the smaller one. Let me change the color to make it more obvious. We pointed to the smaller one, right? And now we start to move the smaller one, the pointer, right, to the next one. Okay, and we compare, we continue to compare these two, and we found that 3 is less than 4. So what we do now is the same. We change this pointer to point it to the smaller one, correct? And finally, we have this 4 left, right? Because the 3 has reached the end of the linked list. I mean, this pointer has pointed to a none, and in this case we have only one sorted linked list left. So the only thing we needed to do is just let the link point to the left sub list, and that's how the sorted linked list become formed. Basically, we want to, as I said before, we want to separate main functions, which is first we want to have a split the linked list to two part from the middle. We input, and then we want a merge sort function. Right, in here we need to sorted list. These two should be sorted. One. Okay. So basically, we want to first we should get the middle of middle part. Actually, in this function, we want to separate both the head and the middle. So which means the left part will be the head, and we put that into this recursive function. We put the head, but remember that the head has stopped. That's in this position. Okay. So after this split function, it has the head becomes just this part, just become 4, 2 part, and right will become the latter part, which is 1.23. And finally, we want to put these two sorted lists into the we want to return the sorted list, right? So this is how the recursion worked, but remember we have to put our base cases in this function, which is if not head or not head, next we will return just head, which means if it's not if the head is known as the input, or the head only has one element, we would just return the head. And let's begin to implement our split function. So basically, the split function would be first of all, initialize the pointer, and while head, and because here we're gonna use slow and fast pointers, 2 pointers, slow and fast pointers, to get the middle, right? But here we want to add a record previous to record the previous middle position, and we want middle mid this pointer to be the slow pointer, and head be the fast pointer, which is next. And because we want this position here to separate the linked list. That's why we need this mid previous pointer, because if we don't have, we just use the middle pointer, we finally stopped at 1, and that is not what we want, right? And we're just gonna put the mid prev as to record, and finally we use the mid prev to get to separate these, to point it to the null, so that they have officially separated. This pointer just gonna be removed, right? This pointer just gonna be removed. And finally, we're gonna return the right part, the final part, and the head gonna just be this part, right? Okay. And finally, we're gonna implement the merge sort algorithm. So let's create a dummy node at first. List node, and we'll put it to a random number, let's say just -1, and the pointer gonna be dummy, and while each of these pointer didn't reach to the end, and we start to compare these two. So if the value of list 1 is less than the value of list 2, our result will point to the smaller one, right? Pointed to L1, and we move L1. We don't move L2 at this point because L2 is still gonna need to stay and compare to the next L1, because L1 is the smaller one, and we don't know if the next one is still smaller than L2 or not. So L2 should stay the same, and if L2 is greater or equal than L1, we get the result linked list point to L2, and L2 starts to move next. And finally, L2 at the result, L is continuously moving, right? So it can update the next node. And if either of these two lists come to an end, we just stop this loop, and whatever it left, let's say if L1 has left on the pointer, we're gonna point to L1, and if L2 has left, we're just gonna point to L2. And finally, we return the sentinel node. Yeah, we return the result using the sentinel node. Right. So yeah, that's basically how we implement this algorithm, and let's see if it's work. Yeah, right. It works, and let's see. So basically, it's not as good as other solution, but it's pretty clear to understand, and hope you enjoy it.